Hello everyone, welcome back to another video. We've got a spell of very interesting weather on the horizon with the passage of Storm Eowyn, named by the Met Office, and which is likely to affect the UK and Ireland Friday into Saturday of this week. Now this is not going to be your normal winter storm. This is going to be an extremely deep low and potentially going to bring exceptionally strong winds to especially the coastal areas of Western Ireland and then also broader parts of the UK as well. And in this video we're going to do a deep dive on the formation of the low, the track, the possible intensity, and then the different scenarios which might bring a different risk of wind to different areas. I thought I'd start off by showing this graphic that I made a couple of hours ago, and this will give you a broad idea of the current situation. So if you're not super interested in the detailed stuff, then feel free to just kind of look at this graphic. I'll break it down a bit, and then you can get a nice understanding of the broad picture. And as you can see, we've got three general different risk levels at the moment. The highest is across parts of Western Ireland here, just about, or no, not quite into Northern Ireland, but the western areas of Ireland. That's where we currently have the highest confidence on a spell of extremely strong winds during Friday morning. Now this is not just your usual winter storm, like I said. This is 80, 90, maybe even 100 miles an hour or more. And that is going to cause damage and disruption no matter where you are, no matter how least kind of low densely populated you are. That's going to cause structural damage, damage to trees, damage to kind of power infrastructure, disruptions to travel, etc, etc. So really, anywhere in this zone, pay attention to the forecast. Still could be changes, and I'll talk about that, but the confidence is increasing on a dangerous and very unusual wind event there on Friday morning. Now, areas in the lighter blue, quite a large area covering all of the rest of Ireland, Northern Ireland, all of Scotland, large parts of Northern England, maybe just about down into the Midlands there, not quite though, parts of Wales and the southwest. This zone, we currently have pretty decent confidence on seeing strong winds in general. Nothing exceptional, just kind of strong winds, gales could cause disruption and that kind of thing. However, we are likely to have a zone within this blue region which does see exceptional winds. Maybe not as high as areas across western parts of Ireland, but potentially just as disruptive, severe gales, especially along coastlines. The issue is, and I'll talk more into this a bit later, we just don't know quite where that's going to be. Potentially it's going to be across western parts of Scotland, even into parts of northern and eastern Scotland. Potentially that's going to be more of the central belt down into parts of northern England and southern Scotland, maybe even reaching into parts of Wales, Irish Sea coast as well. But we just don't quite know where it's going to be, how strong those winds are going to be. Now the remainder of Wales and England, you're just going to see kind of your typical windy weather, unsettled, maybe some low end disruption, but nothing that significant, and definitely not as significant as further west. Now in terms of the track of this storm, you can see it quite clearly there on this kind of black dashed line. Initially going to be moving slightly to the northeast. As it strengthens though, it will start to turn left essentially, move to the north, and you can see it really curves up that direction there. But this is just the current most likely track, and anywhere in white is the current possible spread of the tracks of our low, so it could be further north as this sort of route there. That would bring the risk of winds further west across parts of Scotland, or further south. That would also extend the risk of probably strong winds maybe into parts of the Midlands and the south as well. So that's this graphic kind of looked at, just giving you a broad sense of the current areas most at risk. But let's look at the formation of this storm, Storm Eowyn, and actually it's just in the formative stages now. So this is the Jetstream chart on windy.com. This is the weather model data from the European model that's overlaid in the pressure isobars. And if I go to the satellite right now, what you're going to see is this big band of precipitation across the southern US. And that's actually bringing a spell of snow and sleet to very far south areas. So this is kind of Louisiana, Mississippi, Alabama, Florida, all seeing snowfall, even as much as a foot of snow, which for these areas is very, very rare. And if you think about it, we're looking at kind of the same latitude as North Africa here. So it says a lot about how unusual this cold air is to the far south. And that's a result, we had a kind of a lobe of the polar vortex split off. That's dove into parts of kind of the central US and tightened, the temperature gradients across the southern US, resulting in a fairly strong frontal zone. Now that developed into a low pressure system and is continuing to develop into a low pressure system as we speak. And when it moves slightly to the northeast overnight, that is when things are going to turn interesting. Because if I turn back on that wind overlay, and if we look very high up, this is where the pressure is 300 hectopascals. For context, on the surface it's 1,000, so this is probably high up. You can see 9-10 kilometers or so. And look, Because of that temperature contrast, you've got the very cold air pushing in here, but the air here is still fairly warm. It's in the tropics, the Caribbean. As such, we get a very strong supercharged jet stream, a ribbon of very strong winds, 9 kilometers above, like I was showing you, and that's what's kind of this weird yellowy black ribbon is indicating. And look where we've got the grey colours. This is very rare. We've got winds of over 200 miles an hour in the jet stream, so very, very strong. And when you've got a strong jet stream, what tends to happen is you tend to get very strong lows, and if they move into the UK and Ireland, that's when you have kind of trouble, and that's exactly what we're going to have over the next few days. So this is our frontal zone, located across the far southwest US like that. But this sort of section of the jet stream is not super favourable for intensification because there's not a lot of divergence aloft. Now you need divergence because you want the air at the surface to be filling in, rushing in to fill that gap, and the pressure lowers. What's going to happen is this frontal zone is going to move into the parts of kind of southwestern Atlantic by tomorrow, and you can see that there. If I play through this loop, there's our frontal zone. The chart doesn't seem to be updating, but there we go. It's then emerged into parts of the southwest Atlantic here, and now we've got a consolidated low pressure, and also we're in a much better part of the jet stream, and that's because the two areas we look for low pressure development in the jet stream are the left exit, so where the winds are exiting the jet stream on the left side here because you've got divergence aloft, and the right entrance because of the same thing, you've got divergence occurring as the winds spread apart in the right entrance, and that's where our low is located, the right entrance region. And so what's going to happen is the diverging winds aloft are essentially removing air from the low pressure system, and at the surface the air has to rush in to fill the place, and it rises, and when it rises the pressure drops. So it's almost a bit of a positive feedback loop, and I'll explain a bit more on that in a second, because if you look how the slow develops, it stays still lots of divergence occurring there, winds spreading apart, it continues to deepen. But it's really not until Thursday where the pressure starts to drop rapidly below kind of 1,000 millibars and then deeper. And what starts to happen is the storm then kind of injects its own energy into the jet stream. And you can see hints of that here. The jet stream is curving slightly. That's due to latent heat release, essentially as the water vapor turns into cloud and precipitation, it releases heat, the pressure drops, and that has a kind of impact on the jet stream. It injects energy into the jet stream, and it kind of starts to buckle, and you can see that there, that nice kind of buckling process. And this is what I mean by positive feedback loop, because the energy that the storm injects into the jet stream causes it to buckle, and the buckling pattern is much more favourable for rapid development because you've got divergence of the wind and a lot more divergence as well, which means from this point the low only gets deeper, and it kind of feeds the whole cycle. And it only really stops when the low matures, it moves out the jet stream and it starts to weaken. But this is going to continue for quite a while, and look how quickly the low deepens overnight. By Thursday at midnight, or this is 11 o'clock, 948 millibars. That's exceptional. By Friday at 5 o'clock, 944. So it just continues to deepen, and we can do kind of a 24-hour change. Let's see, when's it should we do between, let's do between 5 on Friday and 5 on Thursday, so 986 versus 944, so basically 42 millibars of difference over a day. Now for context, what we term as what we call rapid deepening is 24 millibars in a day, so a millibar an hour, 24 millibars in 24 hours. This is pretty much twice that. I mean, not quite, because it's 42, but it's getting close to double that rate. So really, to put this into context, this is unusually fast deepening. And of course, by the time it's at its peak depth, it's coming straight into parts of Ireland, and then will then move into the UK. And originally, what the models were showing was that it would deepen kind of somewhere out here, and then get caught in the coal area of the jet stream. So it would slow down, mature, the pressure would fill in, it wouldn't be so impactful. That's now trended to be different, in that it will reach peak maturity over the UK and Ireland and move kind of more quickly through. That brings much stronger winds. Now you may be wondering, I'm being very dramatic, what kind of wind gusts are the models showing? Now take this with a large amount of kind of consideration. This is just a model, and this model in particular really likes to overdo wind speeds. But this is the French arpeggio model. This is what the high-end scenarios could be for Thursday into Friday and then into Saturday across Ireland and parts of the UK. This is sorry, the wind gust chart. Already this is suggesting we're going to have winds of 130 miles an hour, gusts, by the way. Play that forward. This is suggesting 11 o'clock on Thursday, we're going to have wind gusts of 173 miles an hour. And I've never ever seen that colour on this website before. Now, this is, fairly confidently, this is not going to happen. This is probably a result of this model in particular really overdoing that feedback loop I talked about and thinking the winds are going to be a lot stronger than they actually are. But the fact it's even considering 170 mile an hour wind gusts as a possibility is frankly ridiculous, and I've never ever seen anything like that modelled near the UK or Ireland. If you take a look at the sustained winds, suggesting the sustained winds will be 130 miles an hour, which is the equivalent of a Category 4 hurricane. Now, let me repeat that this is not going to happen. This is exceptionally unlikely, and the winds by the time we actually hit land weaken significantly. So it would not be anything like having a Category 4 hurricane hit the UK. Do not take my words out of context. The impacts would not be that severe. But this is just prove to show how exceptional this low is going to be, that some of the models have ridiculous amounts of kind of wind speed shown. But this does lead into my next point quite nicely, that the track of the low depends very much on how it strengthens early on. So in the weather, kind of weather forecasting, the low pressure systems, one of the main driving forces on them is the pressure gradient force, and the pressure gradient force acts upwards, essentially to the north of the storm's centre. The stronger the pressure gradient, the stronger that force is. And so what happens is, if you get a deep low early on, you've got a stronger pressure gradient, and what results is the storm takes a track more to the north. And you can see that on the arpegge model here. Let me just show you the overall weather chart. So in this scenario, we're looking at a very, very deep low, 928 millibars, so approaching record level for this region. But notice how it's located offshore of Ireland and to the northwest of Scotland. Sorry. It would still bring very strong winds to Ireland, Northern Ireland and Western Scotland. But if you compare to the icon, sorry, what happens with the icon is that initially the deepening is a bit less intense than the arpegge model. It's generally taking a track more to the east, as you can see there. But instead, what happens is it reaches its peak maturity over the UK, and as such, the strongest winds actually happen from kind of parts of Northern Ireland up into northern Scotland. Now, the GFS is even less as part of that pattern, has the low reaching its peak maturity slightly later. Actually, to be fair, this is quite similar to the icon, but still, the centre of the low, whereas the arpegge was out here, is essentially just threading kind of the gap between Northern Ireland into Western Scotland there. So you can start to see the picture. A stronger low earlier on leads to kind of, not as you would think, but less impacts, whereas a weaker low initially, but stronger later, leads to higher impacts. And this is the kind of dangerous scenario where we might see potentially 80 mile an hour wind gusts even inland. If you look at the icon, which I think is a reasonable best guess at the moment, what happens is you get this spell of ridiculously strong winds developing out across the Atlantic, but that pushes into the west coast of Ireland. We end up seeing wind gusts well in excess of 100 miles an hour across the western parts of the country, even with winds of kind of 70, 80 miles an hour inland as well. And as that moves to the northeast, those strong winds transfer into parts of kind of Northern Ireland, the region, and then Northern Ireland, the country, and then as well into parts of western Scotland, and then transferring all the way up the west coast, even into parts of northeastern Scotland, seeing unbelievably strong winds. Now, the icon as well as the arpegge often does overdo the wind speed, so don't take this literally, but I mean in terms of the path and the timing and the rough intensity, I think this is unfortunately a fairly reasonable scenario, and I'd probably give a reasonable guess that we're going to see red warnings for a large part of the country, both of Ireland and of the UK, by kind of come Friday. So this is really something which is going to be pretty exceptional. Now, there is still the possibility that things will be different. In this graphic I made, this kind of southernmost scenario, that is still a rough possibility, and you can see the same thing on the GFS ensembles. Sorry, let me move to the Europe, and then here we go. So this is plotting the different possible paths of the low from each of the ensemble members, the lines obviously representing a different ensemble, the colours, the kind of darker the colour, the stronger the low. And that stronger, more out to sea pattern can be illustrated quite nicely with the strongest ensembles, they're out to sea. Now, we are still looking at the possibility of a few of these further south solutions where the low centre is kind of parts of central Ireland up towards eastern Scotland. This would bring the risk of winds across parts of maybe more southern areas, that sort of region. However, I think the risk of that is currently fairly low, and the winds would be weaker as well, which is a good thing. But in terms of the trend, if you compare to 12 hours ago, you can see 12 hours ago the models were much more favouring a arpegge type solution, out to sea, much stronger. In the last 12 hours, you've seen a significant shift towards inland, stronger winds overland, much more disruptive. And whether we see this continue, I don't know. It's probably going to not be as significantly in this direction. I wouldn't expect that, but it's always possible. So this sort of area here, I would keep an eye on the forecast, but not as much as if I were anyone in this sort of region, also parts of Southern Ireland as well. Now I thought I'd talk a bit about the structure of the low pressure system itself. So this is a nice article from the University of Reading. I'll put the link in the description, but it shows the two sources of strong winds in a low pressure system. Number one is what we call the warm conveyor belt, so it's warm air in the warm sector. That's our cold front here, that's our warm front there. It rises up, and this usually brings fairly strong winds, and we can see this quite nicely on the icon model, affecting maybe parts of more kind of southern England. Obviously they won't be as strong. So if we play through our wind gust chart there, this right here is our warm conveyor. Okay, you can't see that pen at all, I just realised. So this right here is our warm conveyor belt. Our warm front will be somewhere in this zone in black. Our cold front is here, and in between we've got that nice region, shows up quite nicely, of 40 to 50 mile an hour wind gusts inland, 60 mile an hour on coast. So even for the far south, it's going to be a windy day, just nothing near as bad as it would be in areas further to the north and west. So that's our warm conveyor belt. Now the most interesting area, because it's got the strongest winds, is where we've got our cold conveyor belt, and that's we've got often cold and very dry air descending rapidly from high levels. And as that happens, it accelerates and the winds get very, very strong. And you can see it happens just behind our cold front. And when we have occlusions, it also happens with our occlusions. And you can see that very, very nicely on the models as well. So there's our cold front, will be located somewhere like this. Our warm front will be there. We've got an occlusion, and notice where the strongest winds are, wrapping behind the cold front with the occlusion. So the strongest winds will be on the southern and western edges of the low centre. And if we track through the metal surface pressure charts, they will be associated with the occluded front there. So you can see currently we're looking at a very large area of Ireland and Northern Ireland, and then possibly into parts of Northern England and Scotland. Still, there is uncertainty with the track of the low. The MOGREPs indicate that quite nicely. Either we could be seeing a track out to sea or something more inland. Either way, going to be very strong winds. But I do think the worst is going to be that further inland track, obviously. The icon, if this were to happen, this would be a historic storm, to be honest. It would be very, very bad. But we're just going to have to continue watching the models for trends, because we do know there's going to be a deep low. We don't know it's likely going to affect, we do know, well, this area of Western Ireland is pretty much certainly going to be affected, but this entire region in black is at risk of very strong winds, and right now I think the most likely this corridor. So going back to the graphic earlier, I think extending this blue area, if I could right now, I would do something like this, but equally there's a possibility of anything kind of in between. Now, there's also going to be the risk of very strong coastal flooding, or severe coastal flooding, not necessarily strong, and that's because it's essentially going to function as the same way as storm surge does in the hurricane. The pressure here is very, very low, 949 millibars. That acts to kind of suck up the sea, the surface of the sea, raises the sea levels a bit, like when you suck on a straw, the water goes up the straw, that but on a less kind of extreme scale. So that's one factor. Another factor is the winds, and the sustained winds will be very, very strong, obviously, as you've seen in the model output. I mean, even 80, 90 mile an hour winds pushing on shore would do the job, but if you've got 100 mile an hour winds pushing on shore, that's going to really physically just push the water into kind of like a surge. And the other thing to consider is the coastline of parts of Western Ireland, because you've got these kind of sort of bays, kind of funnel-shaped bays, and small kind of inlets and that kind of thing. And unfortunately, in this case, they are oriented into the wind. So essentially what's happening is the wind is going to be pushing the water, and it's going to funnel up into these bays, and as a result, I think we could unfortunately see some storm surge, some coastal flooding, some very large waves. We'll have to see if this ends up coinciding with high tides. But where it does, it could be fairly disruptive, really. In terms of rain as well, I actually haven't looked too much at the models for the rain threat, but I would imagine this is a strong low. It's going to be carrying a lot of moisture, and if we just take a quick look at the models here, I mean, you've got the occluded front here. That's going to be pretty rainy, but the main thing will be the wind. But as we get this warm and cold front, that's our warm front, there's our cold front, all the moisture running up into the western hills and mountains, Wales, northwest England, southern Scotland, western Scotland, probably going to see significant rainfall totals there, maybe 50, 60 millimetres over maybe like 6 hours or so, could cause some flooding issues, depending. Yeah, so kind of looking at that. This is just model output for now, but kind of 40, 50, 60 millimetres, especially across parts of South Wales. So that's the current picture for this storm, likely to be extremely disruptive, but we still have details to iron out in terms of the forecast. Now, I appreciate this video probably wasn't the absolute most useful, just because we can't say for sure which region is going to see the strongest winds, but this graphic I think is a nice overall kind of everything together considered, your current chances, and because of how severe this is, I will be doing multiple updates, probably one tomorrow, one Thursday, and maybe one on Friday, we'll see. But if you've got this far, thank you very much for watching, and stay safe, keep up to date with the latest weather warnings and that kind of thing. Bye bye everyone, thanks for watching.